All right, folks. So I'm going to ask you guys to be able to use Excel to be able to work through some data distribution stuff. Okay. And the three that we're going to look at are going to be the Poisson distribution. We're going to take a look at the binomial distribution, and then we're also going to take a look at the normal distribution. And how can we use Excel to try to do some problems that correlate to that? All right. So let's start with I'm going to go ahead and just start with, hold on one sec. Sorry, I'm trying to get to the pencil where I can write things on here. So there it is. All right. So let's say I'm going to start with our binomial distribution. Okay. And you guys might remember with binomial, there's two outcomes, probability of failure and probability of success. Okay. And sorry, I'm writing with the mouse, so it's not as nice. All right. But let's say, for example, that I had the probability of success P was equal to, let's say, 20%. Right. And let's say that the sample size N was something like 15. All right. And a question that I asked you guys on exam 2 was I asked you guys to maybe find the probability of exactly 4 successes. Okay. And if we were to do that, okay, so P of 4, if I were to do that by hand by using our calculations, okay, that would be equal to 15, 4. And then we would multiply that by 0.2 raised to the 4th. All right. And then from there, we would take the complement of 0.2, which is 0.8, and we would raise that to the 15 minus 4, or 11. Okay. Now I'm going to shove that into my calculator really quickly. And if I shove that in my calculator, and what I'm doing is I'm just showing you that this does work. Okay. So 15 combination 4, it's 1365. I'm going to multiply that by 0.2 to the 4th and multiply that by 0.8 to the 11th. All right. So I got 0.1876. All right. Now, it's not that difficult to do that, okay? But if I have a whole bunch of those to do, then it might be a little bit taxing for me to be able to do that, all right? So what I'd like to do is I'd like to show you guys how to use Excel to be able to get the binomial distribution, okay? So hoping, okay, there it goes. Hold on. I'm just making sure you guys can see the screen. Okay. So the function you guys are going to use is something called binom dist. Okay. So in Excel, if I want to know the probability of exactly 4 successes, given the probability of success is 0.2, I'm going to say equal binom dist. It's going to be the number of samples, which was 15. Okay. 4 successes. And then I would say that in this case, the probability of success, hold on one sec, I'm going to enter that in again. I just want to make sure everybody can see this, so I'm going to blow up the screen. So equal binom dist. And right. And then there are 15 possible samples. There are 4 that we want. The probability of success is 0.2. And then what we're going to do is we're going to type in a true. Okay. I'm sorry, we're going to type in false. Okay. Now, we always type in false when we want exactly a specific number. Okay. In a few moments, I'm going to show you what we're going to do for less than and greater than. Okay. So if I hit enter on this, okay. Oh, it said num for some reason. I don't know why I did that. Let's see. So equal binom dist 15. Oh, okay. I'm sorry. I flipped it around. So it's 4, 15. Okay, so so what you always do is you put the number that you desire first, and then the number of samples second. The probability of success is 0.2, and then we're going to go ahead and type in false. Okay, all right. Now I get 1876. Okay, and if we go back to how we did it by hand, okay, we got 1876. Okay, so with Excel, it makes it a lot faster, especially if we have a whole bunch of these to do. Okay. All right. So when you guys are doing the assignment, okay, this what you guys are going to do is you're going to type that in, all right? And then what you guys are going to do is you're right next to it in another cell, you're just going to type, this is the probability of exactly 4 successes. Okay. All right. And I hope I didn't type over that. Nope. Okay. All right. So this is what your Excel assignment should look like when you're going through each of these. Okay. Now, let's say, for example, I want to figure out what's the probability of less than, let's say, 6 successes. Okay. Well, the only thing I'm going to change, oh, sure. Let me go ahead. Kelly just asked me to repeat the order of operations. Sure. I'll just, is it okay if I just type it in again? So that way you guys kind of see the same thing. All right. So if I were to go ahead and just type this in again, I would say binom for the previous. So that would be binom dist. And then it would be 4, which is the number of successes that we desire, comma, 15, which is going to be the number of total samples, comma, 0.2, which is the probability of success, and then false, because I want exactly. Okay. And then if I execute that, that gives me the 818764. Okay. All right. So, oh, no problem. You're quite welcome. All right, folks. If I want the probability of less than 6 successes, I'm going to do the exact same thing. So binom dist. I'm going to type in 6, comma 15, comma 0.2. All right, so it's the exact same inputs, except the only other one that we have is the only thing that's different is 6. And then instead of false, anytime I have less than, I'm going to type in true. Okay, so the only difference between false and true is that we would just is that for false it's exact, for true it's less than. Okay. All right. If I execute this, I get about a 98% probability. Okay. All right. Now, what if I want to know the probability of more than, let's say, 3 successes? Okay. Well, this time, what I would do is I would take the complement of 3. Okay. So what I would say is equal 1 minus binom dist. I would say 3, comma 15, comma 0.2, and then still true. Okay, so folks, the only time that you use false is if you're using exact. Okay, every other time you're just going to use true. Okay, if I go ahead and execute that, I just get 35%. Okay, and by the way, when I'm done, what I'll do is I'll switch back to the commands so that way folks can see them. Okay. All right. What if I want a between problem? Okay, so let's say probability of between, let's say something like 2 and 5 successes. Okay, well, what I would do is I would subtract the probability of 5 and 2. Okay, so that would be equal to binom dist of 5, comma 15, comma 0.2, comma true, close parenthesis, and then minus binom dist of 2, comma 15, comma 0.2, comma true. Right? And then if I go ahead and execute that, that gives me about a 54% probability. Okay, so let me recap the various probabilities for these because they do look pretty similar to one another, and I just want to make sure everybody understands the subtle nuances between those. Okay, so if I want exact, okay, so the probability of exactly 4 successes, I would say binom dist, I would type in the number, I would type in the number of total samples, so number desired, number of samples, probability, and then false. Okay. The only difference between exact and less than is that less than, you just type in a true. For a more than problem, you take the complement of the probability. And then finally, for between, you subtract the lower from the higher. Okay, so whichever number is smaller, that one always goes second. Okay. All right, so before I move on to Poisson, okay, can I answer any questions for folks about how we're going to go through and try to get these probabilities using Excel instead of using the ones by hand? Okay, on the exam, you guys did it by hand. Okay, and there was a problem where I asked you guys for like a less than, and it's a little bit tedious. Okay, but with Excel, it makes it really easy. Okay, so questions I can answer for you folks before we move on. Okay, all right, so let me flip back to that screen, and then I'm also going to do a screen share again for the whiteboard. Okay, another type that I want you guys to be familiar with is Poisson. Okay, now remember with Poisson, the only thing that you need to know is the number of successes in a given interval. All right. So let's say, for instance, okay, I'm looking at the number of, let's say the number of students that visit my office in a given week. Okay. And let's say that's going to be lambda is equal to 21. Okay. And let's say for some reason, I want to know what's the probability that exactly 18 students are going to visit my office, given that the average is 21. Okay, well, we could figure that out by hand. And I'm going to do that first, so that way I can show you that this does work. Okay, so the probability of exactly 18 successes is going to be equal to lambda to the x. So that's 21 raised to the 18th. Okay. And then e to the minus lambda, so that's e to the minus 21. And then I'm going to divide that by 18 factorial, or x factorial. Okay, so same formula you guys used on exam 2. All right, and let me go ahead and stick that in my calculator. Right, so that would be, and if somebody could just verify that this works, that would be lovely. If not, we'll just go with what I get. So negative 21, and we're going to divide that by 18 factorial. All right, and I get 0.0747. Okay, so 0.0747. All right. Now, let's see if that works using an Excel command. Okay, so just remember 0747. Okay, and I'm going to show you guys hopefully how to be able to get this from Excel. Okay. So in Excel, I'm going to use a Poisson dist. Okay, so equal Poisson dist. Okay, or I'm just Poisson. It's not Poisson dist. It used to be Poisson dist. What you're going to do first is you're going to put the number of successes, which in this case is 18. You're going to type in the lambda, which is 21. And because we want exactly, this is going to be false. Okay, so I think our number was 0.0747. If I hit enter, I get 0.0747. In fact, if I'm looking at my calculator, this is accurate out to, it looks like the 10 millionths place. Okay, so it looks like that's a good value. Okay, so this is the probability of exactly 18 successes. Okay, so let me type it in again, okay, just so that way you guys are certain of the order of this. Okay, so you would say equal Poisson x is 18, lambda is 21, and then we're going to type in false. Okay. All right, now let's say I want the probability of, let's say, less than 15 successes. Okay, so let's say I know in a given week, I have 21 students that visit my office on average. Okay, the probability that less than 15 is the exact same command, except I use true. Okay, so let's say equal Poisson. And I'm going to type in 15, 21, true. Okay. And if I go ahead and hit enter, that gives me about an 11% probability. Let's say I want to know what's the probability of more than 25 students visiting my office, given that 21 is the average. Okay, so say 25 successes. Okay, so once again, that would be the complement. Okay, so equal 1 minus Poisson, parenthesis. Oh, spelled it wrong. Okay, I would type in 25, comma, 21, comma, true. Okay, hit enter. It gives me about a 16% probability. Right, and then finally, if I want to know the probability of between, let's say 22 and 29 successes. Okay, similar to our binomial distribution, what I would do is I'd type in 29, I'd type in 22, and I would subtract those two probabilities. Okay, so equal Poisson of 29, comma, 21, comma, true, minus Poisson of 22, comma, 21, comma, true. Okay. If I execute that, I get a 32% probability. Okay. All right, so let me pause and ask if there's any questions I can answer for you all about working with the Poisson probability, okay? And similar to before, let me go ahead and share the actual syntax, okay? So our syntax, okay, remember for exact, okay? One more, let me, Kelly, would it be true or false for the between? Okay, so it would be true for between. Okay, so the only time that we use false is if we want exact. Okay, for less than, greater than, or more than, or I'm sorry, less than, greater than, or between, we always use true for those. Okay. All right. So for exactly, you type in the number of desired, and then you're going to type in the number of lambda and then false. For less than, number desired, or sorry, the number desired, lambda true. 1 minus for more than, all right, and then finally you should subtract lower from higher. Okay, all right. So folks, any questions I can answer about if we wanted to go through and try to do these probabilities using our Poisson distribution? Okay, using Excel. Okay, all right, folks. The other data distribution that I'd like you guys to be cognizant of using Excel is going to be the normal distribution. Okay, and so with our normal distribution, we know that we can do those by hand. Okay, if I give you the mean and standard deviation, you can figure out probability of less than, greater than, or between. Okay, so let me just do one by hand just to show you that this does work. Okay, and then we'll go ahead and I'll use Excel. Okay, so let's say, for instance, okay, let's say that the average on this last exam, okay, percentage-wise, let's say that, or let's just say number of raw points. Let's say that the average of raw points on the last exam was 110. And let's say that the standard deviation for this was going to be something like 11. Okay. Let's say I wanted to figure out what's the probability that somebody scored less than 100 on the exam. Okay, so probability of X less than 100. Okay, well, what we did on exam number 2 was we drew a data distribution, we drew a normal distribution, and we did this on exam 3 too for the sampling distributions. We know that 110 is in the middle. We know that 100 lies to the left, and we're looking for this probability in here. Okay, so, and again, excuse the crude manner with which this is being drawn. So this is 100. And then what we would do is we would go ahead and find a z-score. Okay, so z would be equal to 100 minus 110 and we would divide that by 11. Okay, now our z-score, we would round to 2 places. Okay, so that would be negative 10 over 11. So I got 0.91 negative. Right. And then the last thing we would do is we'd look up the area for this, okay, by looking at the z-table. Okay, so unfortunately, I don't have a z-table readily handy, but I can dig one up. So if somebody has their z-table and they can look that up while I'm looking for one, okay, that would be helpful. All right, and if you could just, once you look it up in the z-table, if you could just type it in the chat, that would be lovely. All right, if I get to it first, then that's fine. All right, so let's see. I got 18141. All right. And that should be our probability. Okay, so that's how we did it before, okay, just by hand. Now, let's see what happens if I were to use an Excel command to be able to figure this out. Okay, so remember, our mean is 110, standard deviation is 11, and the value that we're looking at is less than 100. Okay, so and 1814.1. All right, so if I were to go ahead and use Excel for this, okay, first thing I would do is I would say equal norm dist. Okay, X is 100. Okay, so remember 100 was the number of points. The mean was 110. The standard deviation was 11. And I'm going to type in true because it's the less than problem. Okay, so remember we had 1814.1. We get 1816.5. Okay, Excel does a little bit different rounding. We're accurate out to the thousandths place. Okay, so that's pretty good. Okay, so there is a little bit of variation between what we have in the table and what Excel does. No big deal. Okay, so this is the probability of less than 100. Okay, now what if I wanted to know what's the probability that somebody scored more than 120? Okay, and it would be probability of that. Okay, so just like the others, what I would do is 1 minus norm dist. Okay. The X in this case will be 120. The mean is still 110. The standard deviation is still 11. And I'm still going to type in true. Okay, so the only difference between less than and more than, just like in the other two cases, is you take the complement, 1 minus. Okay, all right. If I execute this, that just gives me another 1816.5, which makes sense because they're both equally distant from the mean. Okay, so remember, both 100 and 120 are 10 units away from the mean. Okay, so we would expect to get the exact same probability. Okay, all right. If I want between, or probability of between, let's say 115 and 125. Okay, just like we did with the other two, I would figure out the probability of 125, figure out the probability of 115, and subtract those. Okay, so equal norm dist of 125 or 125 comma 110 comma 11 comma true minus norm dist of, what we say, 115, I think it was, comma 110 comma 11 comma true. Okay. And if I execute that, that's going to give me about 23% or 24% rounding. Okay. All right. So just looking at those commands again. Okay, there you go. All right. And in fact, what I'm going to do is I'm just going to show all of them so that way you guys can see them all. So that way, if you wanted to scroll through and pause to the end of the video, you could see them all in like one shot, just to make sure that you guys have everything in one. Okay. So again, for norm dist, okay, you type in whatever the X value is. Okay. Then you type in the mean, then you type in the standard deviation. For norm dist, you're going to use true all the time. Okay. Because we're not going to find exactly anything. Okay. All right. So any questions I can answer for folks about anything on the technology assignment or any of the commands? And I am going to go through like the actual assignment just so that way you guys can see what it looks like. All right. But questions I can answer for folks. Okay. All right, folks, really quickly, just to remind you guys where to find this. Okay, so let me go ahead and I'll bring up my Blackboard. Okay, so what you guys do is you go to Blackboard. Okay, you go to Intro Stats, you go to Documents, Quizzes, Technology Assignments. You're going to scroll down to Technology Assignments and go to Assignment 3. Okay, let me go ahead and bring it up so that way you guys can see it. And Here it is. Let me blow it up a little bit. Okay. And so what you'll notice is part A, asking you guys to use the Poisson distribution. Okay, so lambda's 45, and then here's your various x's. Okay. For part B, I'm asking you to use the binomial distribution. Okay, here's your probability of success. Here's your sample size. Okay, and then here's all the x values that you would use. So 1, 3, and 5. Okay, and then finally, here's the normal distribution problem. Okay, here's your mu, your lambda, here's your mean, here's your standard deviation. Okay, and then here are your x's. Okay, all right. So, and then down here, I do have the commands, okay, just in case you want to take a look at them in general. All right, but most of the time, students are pretty good if we go through and just use the video stuff. All right. So questions I can answer for anybody about technology stuff, okay? And everybody remembers it's due May 1st, along with quiz number 10 when we go through things. Okay. All right, folks. The other thing I wanted to make sure of is that you guys are good with the capstone stuff, or if you had any specific questions about capstone stuff, okay? So just kind of going back to our timeline of when things are, or like to be on pace, if you would, okay, for being able to complete things, all right? Remember, guys, one of the things that you guys should be done by this week, okay, is you guys should be done with collecting data, okay? And then also, you guys should be writing at least the intro and some of the research stuff. Okay, so that should be done probably by tomorrow. Okay, if just keeping on a good pace of things. Okay, so, and I'm not, by the way, I'm not collecting any of this stuff at this time, but you know, just thinking about like, you know, that this thing's going to be due in about a month or 3 weeks. This should be a pace that you're on. Okay, so this would be for April, let's just say 22. All right, so that way you guys can have till tomorrow to do that. All right. Now, next week is where you guys want to do something with the data, okay? So that's where you're going to talk about like your collection methods, and then you're going to summarize the data, okay? So, okay, and then data summary, okay? And what I mean by data summary is, I mean, okay, you've put it into a histogram or like a bar chart, all your data, or frequency distribution, okay? That sort of stuff. And of course, when I'm talking about collection methods, okay, I'm talking about, did you use simple random? Did you use convenience? Those sorts of things, okay? And then talking about any anomalies that might have occurred with respect to your collection, okay? All right, so again, that would be sometime next week, April 29th, okay, would be kind of like a good pace for you guys to be on with this, okay? The week after that, that should be the last week that you guys are really working on the project in general. So this would be the hypothesis test. Okay. And I know for some folks, we're still working together to be able to find a hypothesis test. Some of you guys, I've told you what's a good approach. Some of you guys are still kind of figuring that out. Okay. So that would probably be something that we work on together, okay, to figure that out. Okay, so, and when I say hypothesis test, that means you've gone through, you've set it up, you've worked through it, and you come up with a conclusion based on your data. Okay, so that would be like May 5th or 6th. I'm trying to look for, it looks like May 6th would be kind of a good deadline for that. Okay, all right. Now, the next week, that's where you guys would want to go ahead and just come up with any last minute revisions. Okay, so you want to submit a rough draft. Okay, you want to create the PowerPoint from your paper. Okay, and then you want to do any edits. Okay, so that would be May 13th would be a good sort of deadline for that. Okay, and then the week of May 15th, okay, that's when you guys would go through and you had the final paper. Okay, so you would submit the paper, and then also you would want to make sure that you guys do your presentation. Okay. I did get a few requests already for folks that wanted to do virtual. Okay. For those of you guys that absolutely think that you'd rather do it virtually than in person, just shoot me an email. Okay, first come, first serve, or if there's a certain day that you prefer to do it on, I'll do my best to accommodate everybody. Okay. Again, and I think I said this last time, and I'll say it again. I do expect everybody to show up, even on days that you're not presenting, and be on time. It would be horribly, I guess, inconvenient if there was only one person in the room when somebody's presenting, and you certainly wouldn't want that, especially if I was that one person, because I'd be glaring at you the whole time and there wouldn't be an audience for you. Okay, so do make sure you're on time, do make sure you're there, learn from your peers. Okay, it's basically a mini conference. Okay. All right. Oh, and one other thing I neglected to mention in the May 15th or the May 13th, that's also when your abstract would be due. Okay, so let me kind of put that in there. Okay, right here. Abstract. Sometime during like May 13th. All right. It might be like I might make it like that Friday, just so that way I can have the weekend to kind of get these together. All right. Not abstract. Okay, abstract. Okay. So, all right. So that's sort of like your timeline at this point. Okay. And remember last time I showed you guys where to go to look for samples and all that good stuff. Okay. All right. So does anybody have any questions about going through and doing this capstone business? Okay. Or does anybody have any questions in general about capstone stuff? Okay. One last thing. I do know several folks are having a bit of difficulty collecting data. Okay, so I do want to make sure that that folks are you're helping your peers out with this. So for those of you guys that haven't done this, okay, if you guys would go to the announcements page, all right, and if you scroll down a little bit, okay, I have 3 forms. It's on one of the posts from April 14th. Okay, if you guys would. And if you guys haven't done this yet, take a few moments to complete these. All right, there's only 3 of them. Okay, it won't take too long. So just do your peers a solid. Okay, and complete those. Okay, I'm sure it'd be very helpful for them to make sure that they get some data. Literally, I took all 3 of them, and they took me about 1 minute a piece. I think you guys can spare a minute to be able to do those. Okay. All right. So any questions I can answer for folks about anything regarding course or anything regarding capstone before we depart? Okay. So folks, make sure that you guys fill out those surveys for your peers. Okay. Also make sure that you guys are working on your technology assignment due not next Monday, but the following Monday, which is going to be May 1st. And then next week, what we'll do is we're going to start looking into hypothesis tests of 2 means. And then also we're going to start taking a look at the chi-square distribution, which is going to be the stuff on quiz number 10. Okay. All right, folks, I'll post this video. It'll probably take me about 20 minutes to upload it and then post it. So that way, if you want to get started on this, you're welcome to. If you have any questions, you guys can hang out. I'll answer whatever I can. If not, have a great weekend. I will see you all Monday. Take care.